Hey, hi guys. Welcome back to 360DigiTMG's domain analytics program. And it's been 5 days since we are discussing about the insurance and banking domain analytics. And today we'll be discussing about supervised learning, what exactly the supervised learning that we have discussed in the previous session. So it is the second algorithm that we will be taking when it comes to supervised. Yesterday we have discussed about KNN, K nearest neighbor algorithm. We have tried to understand what exactly mathematics, what are the mathematics, and what is the main, process that happens behind the KNN algorithm. We have understood, and then we have used one use case scenario, and then we have predicted the output. Output we have predicted it in the last session. So what is that? based on the features, region, based on the particular person health conditions, whether he has smoking habits or not. The various inputs we have taken, age, various inputs we have taken. Based on those inputs, we have predicted what exactly the insurance price, how much he has to pay for that particular insurance that we have predicted in the last session. So it is a part of supervised. Like that, we have taken the various use cases when it comes to unsupervised as well, unsupervised and supervised. So before starting today's session, that is the decision tree algorithm, we'll go through what are the topics that we have covered till now, so that you will get an idea. And if you want to go back and if you want to revise those topics, in that case, you can do those revisions. So till now, we have completed the 5 sessions. The very first session, we have talked about the applications of machine learning and AI when it comes to banking as well as insurance analytics. And second day, we have understood what exactly is XML. So in order to implement the data science project, we have one standard procedure, right? Standard management. So that is CRISP-MLQ methodologies that we have understood, and what are the phases in that, what are the various phases we'll be having, how those phases will be working, what exactly we will be doing in each and every phase. So what are the each and every phase contains? So all these things we have seen on the second day of the session. And then on third day of the session that we have discussed, pre-processing. What are the various pre-processing techniques we'll be having for both structured data, that is numerical data, I can say, and unstructured data, that is textual. So like that, what are the anomalies that can be found when it comes to structured data? What are the anomalies that we will be finding when it comes to unstructured data, and how we will be overcoming those, or how we will be cleaning those data that we have seen on the third day of data analytics, domain analytics. And fourth day, we have taken one unsupervised algorithm, that is k-means. So what exactly the supervised and what exactly unsupervised, that you might be having an idea since you have discussed various times. Anyway, I'll be going through very briefly. When you have a labeled data, in that case, we will be going with supervised. When you don't have a labeled data, unlabeled data, in that case, we will be going with unsupervised. Among those unsupervised, we have discussed k-means algorithm, how k-means algorithm will be useful to do the segregation, various segregation will be doing it. So we have taken one use case scenario and we have applied it in real time. And on fifth day, on the last session, we have discussed about the k nearest neighbor. So it is one of the supervised algorithm. So what we will be doing when it comes to supervised, what is the process that we have gone through and what is the mathematics behind the k-means algorithm, based on what it will be doing the classifications, all these things we have discussed in the last session, and we have taken one use case scenario. Similar to that, today we'll be discussing about one of the supervised algorithm, that is decision tree. So what exactly the decision tree is and how it will be useful. This whole decision tree will be useful for the classification, and which base it will be doing the classification. What is the mathematics behind this decision tree? So all those things we'll try to understand in the today's class. Without wasting any time, let's get into the session. Before that, what is the agenda for the session? We'll see. First, we understand what exactly the decision tree is and how to build a decision tree. And greedy algorithm, what exactly the greedy algorithm is and how it will be helping you to find out the classes, which class that particular data belongs to, and how it will be helpful to create a classification, how we'll be building the best decision tree model, and what are the factors that will be taking into the consideration, attribute selections. So how we will be selecting the features, various features will be having, and among those, which one we will be considering as a root node, that is also we'll be looking into, and information gain. So what is the information gain and how it will be helpful for us to find out which feature having the maximum information. So that is also we'll try to understand, and then we'll apply one use case scenario. And what is the decision tree algorithm will be having, right? We'll try to implement it and we'll do the classification using the decision tree. So this is the agenda for decision tree classification. Yeah. So what exactly the decision tree? What are the components we'll be having in decision tree? We'll go through it. In a decision tree, the non-terminal nodes and the terminal nodes are different. So when it comes to components of the decision tree, we have three components. One is root node. The main node we will be having, how we will be deciding which one will be the root node and which is not, we will be discussing in detail. So it is one of the components, that is root node, and then we have a decision node. So middle level decisions we will be taking using the decision node, and then we have leaf node. So this is also called as terminal node or decision node. This will be calling it as terminal node or decision node. So these are the three main components we will be having when it comes to decision tree algorithm. Non-terminal nodes are used to make local decisions. So here, this decision nodes will be calling it as non-terminal node. Will be used to make a local decision. So in order to do internal decisions, for that we will be using this non-terminal nodes, and terminal nodes are the final. So these are the final decisions. Once the decision has been made, in that case, we'll be using the leaf node. Apart from root to leaf, we present the classification. So this from root to leaf node, from root to leaf node, from leaf to leaf node. This constitutes one rule. A decision tree consists of 3 types of nodes. So these are the 3 components we'll be having: root node, decision node, and the leaf node. Decision tree is a decision making tool, and based on how we will be doing the decision tree algorithm falls under the category of supervised algorithms, like we have discussed. It works for both continuous as well as category output variables. So it is not just for the classification. We won't be doing just classification using the decision tree. We can do regression as well. If it is continuous data, if you have a labeled data as a continuous, in that case also we will be using this. If it is having the classic, categorical or discrete data as an output, in that case also we can use decision tree algorithm. So both for the regression as well as classification, we will be using this decision tree. So simple, one example we'll take. We are having features. Age we have, district we have, and age and district will be having. So whatever the data that we will be having, we are simply categorizing, and then we will be doing the one decision tree. Insurance claims, especially we will be applying for the insurance data, right? So age, if it is less than 25, it is one discretization. So whatever the continuous data will be having, or the data that we'll be having, this will simply convert into bins, various bins. So what we have done here, whatever the data that is less than 25, in that case I'll be taking it as one category, one bin, and 25 to 29, that is one more bin, 30 to 35, one more bin, and if it is greater than 35, in that case one more bin. And districts, and it is one more feature I'll be having district. And if you combine both, in that case I'll be creating something like this. If it is less than 25, and if it is belongs to district 4, district 3, district 2, and district 1. So it is one classification we are doing. If it is in between 25 to 29, in that case the various districts, age, as well as insurance claims, from which district we are getting the maximum insurance claims. So we don't really have much data here, but how the decision tree will be doing the classification. If it is age is less than 25 or 29, in between 25 to 30, 25 to 30, in that case district 3 and 4. In that, how many claims we have? Here, how many claims we will be having? And if it is not, if the age is not in between 25, less than 25, and in between 25 to 30, in that case, how many claims will be having? So if you have age in between less than 30, let's say overall less than 30, in that case, claims you will be having very less. But here you can see maximum number of claims you will be having if it is not this category. So if it is not in between 25 to 29, in that case, maximum plates will be having. So like that, simple algorithm we can able to split it and then we can make a decision. So let's say a small example will take how decision tree will be working and how we can form the rules out of it. So let's say it is 8 p.m. So it is the time for the dinner, right? Normally, first question what you will be asking whether you are hungry or not. Whether you are hungry or not. If you are hungry, in that case, you will be going out for it is hungry and it is not. If you are hungry, in that case, you will be going out for the dinner or you will be having it home, or else you can simply go sleep. If you are not hungry, in that case, you can simply sleep. So if you are hungry, we'll ask few more questions. How much money you have in your hand? So if it is more than 1,000 rupees, in that case, you will choose some fancy restaurants and then you will be having the dinner. If you are not having greater than 1,000, yes, and it is no. In that case, what you'll be doing, you will be going out and you will be having the roadside dosa or something that we'll be having, and you'll be going to sleep. So in order to achieve this sleep, here also you'll be going for sleep. Here also you're going for sleep and then. So in order to achieve this, how many ways we can do that? So based on the conditions we'll be having, this many ways we can achieve the same solution. Similar to each and everything. So it is a terminal node, it is a terminal node, and it is a terminal node. Each and every terminal node represents one rule. Each and every terminal node will represent one rule. Similar to that, let's say you have a children. If you have a children and they ask one more example will take so that it will be a concept will be clear. Children, if you have a children, he'll ask you that he want to play. He will go out play. In that case, first thing what you will be looking at, what is the weather? So he asks you to, he want to go out and play. So in that case, we'll see what kind of weather we have. First, and it is hot. Chilled weather, and we have a rainy. So these are the three options we have. If it is hot, in that case, what is the temperature? If the temperature is greater than 30 degrees, you'll be saying no, no play. If it is hot, if it is not less than 30, in that case, you might be allowing him to go and play. Yeah, you can play. If it is having chill weather, in that case, you can simply say, yeah, you can go down and play. If it is raining, how much it is raining? That is heavy rains and raining, yes, and it is no. How much it is raining? Whether, I mean, you will be having the winds as well, strong winds. You'll be checking that. If yes, in that case, no play. And no, in that case, you might be saying that go play or shouldn't play. If there is no rain, in that case, you might be saying you can play. So like that, even just to let your children go out and let them play, you have these many conditions. So these are all what we are doing now. What exactly we are trying to do? We are making a decision by considering the various scenarios. If it is hot, what is the temperature? If it is greater than 30, in that case, we will be saying no. If it is less than 30, in that case, you are saying yes. So these are all the rules. This is one rule, and this is one more 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 rule. These are the various rules. So this is how decision tree algorithm will be working. Will it split it, and wherever there is a chance to split it, it will split it and then it will make a decision out of it. So this is how decision tree algorithm will be working. Same when it comes to insurance policy analysis using a decision tree. First, is policy claim is made or not? Yes, if it is made, are you within the policy period? This kind of decisions will be taking, right? Are you paying the premium? Is it in that time period or not? So if it is yes, in that case, go to policy coverage decision tree. If not, are you with the discoverability period? So these are the various decisions we will be going through in order to approve that claim. Is claim clause made? Yes. If it is not made, did event given rise to the claim occurred during the policy period? Go to the policy coverage decision tree. Consider getting second opinion. See expert contacts. So like that, we'll be making a decision by splitting the various options. Wherever there is a chance to split it, in that case, we'll be splitting it and then we will be making the decisions. So this is basic understanding about basic idea about the decision tree. The same thing we will be doing. The amount of damage, how much it is? Less than or equal to insurance demand transfer or greater damage. In that case, whether you have to go with the insurance policy or not, or whether we have to approve or not, like that. For each and everything, we will be having the various conditions, We'll split those conditions wherever there is a chance in that case, and then we'll go through each and every condition, and then we'll be making decisions out of it. So how supervised? All supervised models, what we'll be doing first, whatever the data we'll be having, we'll be splitting into train and test. First, we'll be training it, splitting into the training data and then testing data. Whatever the training data we'll be having, we'll be training the machine learning model. That is here decision tree model. Use training data to build a model. Pre-generate determinants. So what exactly is which variable to split at a node and what will be the value of the split. So let's say we have considered these are the features x2, x3, x4, and then we have widen output. So these are all various variables, right? From where I have to start splitting, whether should I start with x1 and x2 or x3 or x4? Which one I have to consider? So this is one thing we have to look into. So which one we have to consider, which column or which feature will be holding the maximum information? We don't have any idea regarding that. So what we will be doing, we will be doing the iterations. First, I'll be taking x1 as a root node, and then I'll be splitting the whole decision tree. And then I'll find out how many number of rules I will be having for x. The same thing I will be doing with the x2 as well. We'll be splitting the x2. We'll take x2 as a root node, and then we'll start splitting. Once it is done, in that case, we'll be calculating how many rules we have formed. Calculate the rules. So for this also we'll be doing some rules, right? Rules means how many number of terminal nodes we'll be having. Again, we will be considering x3 as a root node. Again, we'll be splitting into various. Again, we'll be splitting into various. And again, I'll be considering x4, and again, I'm splitting into decision tree. So among all the decision trees, whichever giving least number of rules. Among the all decision tree, whichever giving the least number of rules, that decision tree I'll be selecting as the best one. So we are looking for the decision tree which is having the least number of rules and will be giving the maximum information. So that yields the best decision tree. So decision to stop. So when exactly we'll be starting with, we are supposed to stop that algorithm. Okay. Which variable to split at node and what will be the value of the split? Decision to stop, make a terminal node or a split again. Assign terminal nodes to a label. These are the conditions that we'll be looking into. Decision tree regression is a model in the structure of decision tree to predict the data in the future to produce meaningful continuous output. So we'll be using both for the regression as well as continuous that we have discussed, right? So these are the conditions we'll be looking into in order to form the decision tree. So this is how normally a decision tree looks like. So this is a root node. So we don't know first which one we have to consider as a root node. Then in that case, we will be randomly selecting each and every feature, whatever the features we will be having in our data set. We'll be considering each feature as a root node, and then we'll be building a decision tree wherever you are getting the least number of the rules. We'll be considering that as a best decision tree. Root node, it is a branch node. Middle level of decisions will be taken by the branch node, and then we have terminal node. Those are the final, or you can say leaf node. So here we'll be having the greedy algorithm, and how does greedy algorithm will be helpful. So we have seen, right, when you are forming variable, whatever the features will be having, let's say just 4 features. In that case, we can consider each and every root node as a each and every feature as a root node, and then we can form a decision tree wherever it is having the least rules. In that case, I'll be considering as best root node. Fine, but how many you'll be going to? Let's say 15 features will be having. In that case, 15 features we have to consider individual. If it is 130, in that case, 30 features we have to consider individually, and then we have to come up with the concept. So it is not easy. So much calculations involved. Instead of that, we will be going with greedy algorithm. Greedy means greedy for the data. The more number of data you have, in that case, better it will be giving the classification. Yeah, greedy algorithm is a basic algorithm pre-constructed in the top-down recursive divide and conquer manner. So what exactly it is? Top-down recursive manner only we are discussing. We are splitting the data, right? So first root node and branch node will again splitting, and then we'll be having leaf node. Root node, branch node, and the leaf node. Like that, we will be splitting the data decision tree in a recursive manner, divide and conquer manner, and then we will be coming up with one conclusion. At start, all the training examples are the roots. So, like we have discussed, x1, x2, x3, all we are considering as a root node, and based on that, we will be building the decision tree. Attributes are categorical. So, whatever the features that we are considering should be categorical, means discrete. If it is not, in that case, what we will be doing is we'll simply converting those continuous values into the discrete values. So if we have a continuous data in those inputs, what we'll be doing, we'll simply convert those continuous data into discretized values. Input data is a partitioned recursively based on the selected variables. Selecting variables, we will be doing the splitting, right? That is, test attributes at each node are selected on the basis of heuristic and statistical measure. Information gain. So how we will be calculating that and all those things we'll try to understand in detail. So when we will be starting that recursively, we will be doing the splitting, right? When exactly we will be stopping it? when we should stop. So when we will be stopping, so what are the conditions we'll be having? All samples for the given node belong to the same class. So let's say COVID, based on the data, I'm deciding whether that is a COVID positive or COVID negative. When I'm splitting based on some feature, let's say cold, based on the cold I'm splitting. So this one and this one. So in this, we will be having labels, right? If all the labels belongs to it is a positive and it is a positive COVID, and it is a positive and it is a positive. So all the belongs to the same, right? It is homogeneous. In that case, we can simply stop because we can able to make decisions here. So if it is no, it is a negative, positive, negative, right? If it is having all the negative homogeneous cases, in that case, we can simply stop here because we can able to make a decision. So wherever you are able to make a decision, you can simply stop there. So this is where we will be stopping that recursive classification, or you can say splitting the tree. There are no remaining attributes for the further partitioning. So if you don't have any attributes left to do the partition, in that case, we can stop there. And there are no samples left. In order to do classification, we don't have any samples. Just one entry we have, let's say cold and fever, and here we have status COVID positive. Just one entry I have. In that case also we can simply stop because we can able to make a decision. So like that we will be stopping that decision tree splitting. Condition will be stopping the partitioning. Whatever the partitioning will be doing, we are simply stopping it. So that is one approach that we have gone through, and there is one more approach that is using the information gain. So how we will be doing that? We'll try to understand. In order to understand the information gain, you have to have an understanding about the entropy. In order to understand entropy, what is the entropy? It is a measure of impurity. It is measure of impurity. So what exactly is the impurity that we are talking about? Let's say we have splitted based on some condition. Here we'll be having 4 entries. It is a cold we have, and we have fever, and we have cases that is status positive, negative, positive, negative. So here you can see 2 positive we will be having and 2 negative will be having. Can we able to make a decision saying that it is if you have a COVID, fever and cold, in that case it is a COVID positive or COVID negative, can we able to make a decision? So it is not a homogeneous. In that case, you won't be able to make any decision there. So here 50-50 chances. So wherever you are not able to make a decision, that we will be calling it as impurity. When you have a 50-50 chance, it is like tossing a coin. So in order to predict one particular person having the that COVID or not, instead of doing the prediction, we are simply tossing a coin 50-50 and saying that in that case we will be having the maximum impurity. In this case, 50-50. In this case, we will be having the maximum impurity. So how much is the impurity? 100%. That is 1. So we will be representing as a 1. So when you have measure of disorder, that we will be calling it as impurity. That is, we will be calling it as entropy. We will find the entropy of the output values of the set of training instances. If output value is splitted in between 50-50%, set is impure. So maximum impurity will be having, that is entropy. So it is how much? 1. The same way, yeah. Here we have, right, the positive, negative we have. Let's say it is also positive. In that case, 75, 25. So here you can see, here we can't take a chance at all. We can't say that it is a positive case or it is negative case. Absolutely no, 50-50 chances we can't take it. So here we'll be having maximum impurity, but when you have this 75%, 75, 25, it is a, you can say that, yeah, there is a maximum chances, it could be positive because 75% chances will be having. So here we can make little bit of decisions in that case, how much entropy will be having when it comes to 25, 75 set. So it is a 0.81. So if it is a 50-50, in that case, we will be having the 100%. And if it is 0.81, if it is 25-75, in that case, we'll be having the entropy that is 0.81. So this is the entropy. So how entropy will be helpful for us to find out the information gain, we'll see now. Yeah. So information gain, how it will be helping us to find out the best root node. We will see how we'll be calculating that. So it is based on the entropy. When you have 50-50 percentage, in that case, you won't be able to make any decisions. Right? In that case, we'll be calling it as impure. So 100% impurity will be having because we won't be able to make any decisions. If it is 25-75. 25% and 75%, in that case will be calling it as impure one. How much impurity will be having? 0.811. So the information gain, when exactly will be stopping, that we have already seen. Information gain, how we will be calculating the information gain? Information gain, how we will be calculating this? We will see that. First, so whatever the main data frames will be having, the whole data frame and the classes will be having, right? Since it is a decision tree, we'll be using the label data. First, we will be finding out the information gain for the whole data frame. The information gain is based on the decrease in entropy. If you are having the less entropy, in that case, maximum information gain we will be having. Entropy after data set is split on attribute. So what we will be doing before split, entropy, and entropy after split. So first, before split, we will be having the one data set. It is the same for all, and after split, it will be varying for various features that we will be considering. So that difference we'll be calling it as information gain. Information gain. Entropy before split and the entropy after split. That difference will be calling it as information gain. So constructing a decision tree is about finding the attribute that returns high information gain. So various attributes we are considering, right? Each and attribute, what happens after the split? How much entropy we are getting after split? Before split, it will be the same for all, but after split, entropy will be changing. That difference, each and every attribute difference will be finding out. Wherever we are getting the maximum, wherever it is getting the maximum, that means it is giving maximum information. So like that, we will be coming up with best root node. Previously, what we have done, we have taken all the features, whatever the input values we have, all the input columns will be considered as the root node, and then we have found out how many number of rules we have, So based on those rules, wherever you are having the least rules, means maximum information. Least rules means maximum information, and here maximum value, the difference, entropy before splitting and entropy after splitting. If it is having the maximum information, in that case, it will be giving maximum information. So like that, we will be deciding which root node, which feature we have to consider as a root node. So this is a formula in order to find out the information gain. So first, so sigma I is equal to 1 to m pi log to pi. So here we will be considering, let's say you have just two classes, that is S class and no class will be having. In that case, how can we write this formula? Minus pi log to, it is S class and S minus P no log to P no. So probability with respect to S, probability with respect to no, we are taking, and then we will be finding out the entropy. So like that, we will be calculating for the before splitting. This is the entropy before splitting, and then we will be finding out the entropy after splitting. So subcategories, whatever the subclasses will be having, that will be taking on the numerical, and total we are taking the below. So this difference we will be calling it as information gain. Information gain, entropy before splitting minus entropy after splitting. That difference will be considering as information gain. Information gain. Like that, we will be coming up with information gain. So if you have a maximum information, in that case, we'll be considering that decision tree as a best decision tree. So what are the advantage we will be having over decision tree? So what are the advantages we'll be having using the decision tree algorithms? We have various other classification algorithms, right? So what are the advantages we'll be having? So maximum explainability. So there are so many algorithms that is coming into the market every now and then. Among the all, decision tree will be having the best explainability. So let's say, one example, loan. You are doing the loan prediction. A loan prediction we are doing. So in order to decide whether we have to give a loan to one particular person, that is approve or reject. In order to approve or reject, we need to consider few features, right? Let's say these are the features. I have considered the salary, I have considered the age, I have considered the job he will be doing, whether he has any collateral or not. Like that, various we'll be considering. Based on that, I'll be predicting whether status approve or reject. Approve or reject. If we are going with the AI, neural networks, if we are building the same data, you are building the AI algorithm. If you are building the AI algorithm, so what happens? You won't be having any explainability when it comes to, even though you are getting good accuracy when it comes to artificial neural networks. If you are going with the model building using the ANN, in that case, you will be getting the good accuracy, but you don't have any explainability. So let's say one particular client or one customer have applied for the loan. One customer applied for the loan and you have rejected. When you are using the AI algorithm, yes, it is predicted saying that reject the loan. So in that case, definitely customer will be asking for the, what is the reason behind it? Why did you reject my loan? So in that case, what you will be doing? So you can't say that. What are the features that you have considered based on what you have rejected that particular loan? So you won't be having any answers. Instead of that, what you can do, we can go with the decision tree algorithm. What it will be doing, it will go through each and every condition. And it will tell you what are the conditions it is considered to approve that loan or the reject the loan. So you can simply able to explain. So these are the features I have considered, and you don't have that. You haven't. Yeah. So these are the features we have considered, and it is not satisfying these conditions. In that case, we have rejected your loan. You can something simple, something like that. You can simply say when you have a decision tree algorithm. So when you are going with the decision tree algorithm, in that case, you have a maximum explainability. Compared to other algorithm, decision tree requires less effort for the preparation. So while doing the whichever the classification algorithm that we are going with, we have to do the pre-processing. We have to go with the standard pre-processing, right? But when it comes to decision tree, you can skip few pre-processing steps like that. Like what? If you don't have a normalized data. So x1, x2, x3, it is the range in between 0 to 1. It is a range in between 1000 to 15,000. It is a range between 20,000 to 1 lakh, something like that will be having. It is not normal data. So we have to convert into normalization or standardization based on our requirement. But this you don't need to do when it comes to decision tree. It is capable of handling this non-normal data. Decision tree does not require scaling of data as well. So standard scalar will be using, right? Min max scalars. So we don't even need to do the scaling of the data as well. It will able to handle that data as well. So it won't really affect decision tree algorithm. So we don't need to do this scaling as well. Missing values in the data also do not affect the process of building a decision tree to any considerable extent. So if we have a missing values in our data, that is also doesn't affect our model. So these are the advantages we'll be having. And decision tree model is very intuitive and easy to explain. So explainability, like I've explained, that like I have given example, explainability. Explainability is very good when compared to the decision tree with any other model. So that is the reason we will be going with decision tree. These are the advantages we'll be having over any other algorithms when it comes to decision tree. So what are the disadvantages we will be having? Even though there is a small change in the data, can cause large change in the structure of decision tree, causing instability. See, based on when you are splitting the data, based on that we will be splitting, right, various like that we will be splitting. Even though if you are changing the smallest data, in that case, the decision might change. The whole tree should be restructured. That is the reason, even though there is a slightest change, small change in the data cause large change in the structure of decision tree, causing the instability. Whatever the accuracy that he has shown previously, you might not be getting the same accuracy after that. So that is the one thing you have to keep in mind. For a decision tree, sometimes calculation can go far more complex compared to the other algorithms. So when you have more number of data and features, in that case, you can get into the maximum calculation. When calculations increases, in that case, cost with respect to that particular algorithm also increases. So that is one more thing. Decision tree often involves higher time to train. In order to train decision tree, it will take a lot of time because it will be going through each and every data point That is the reason it will be taking the maximum amount of time. So this is the one more disadvantage it will be having. Decision tree training is relatively expensive as the complexity and time has taken more. So each and every data point it should go through, and then based on that it will be training. So and the time taking it is also more. So it is a expensive model compared to the other classification algorithms. The decision tree algorithm is inadequate for the applying a regression and predicting the continuous values. But we have to make few changes, and then we can go with the regression. One of those is random forest. Random forest, we can. It is also decision tree based algorithm. We can do both classification as well as regression. So these are the disadvantages and advantages when it comes to decision tree. So we'll see one use case scenario. What exactly that use case is? Insurance claim fraud detection. So in insurance claim also we have so many fraud happening. So how can we detect those frauds? That we will try to understand. Before that, what are the data frames? What data frame will be having? What is the data description? We'll see. Data consists of insurance details of different customers. There are very small data we'll be having. Just it is a base model, so I'm considering this 1,000 records. So this is how the decision tree algorithm will be working. Now we will go through, we will be having one use case scenario. We'll try to understand how we can implement the decision tree algorithm when it comes to real time. So here we have one use case. What exactly that use case is? So when it comes to insurance, there are so many fraud claims will be happening, right? So among those fraud claims, so which one is the fraud one? So various claims will be having among that, which is the fraud one. In order to detect that, these are the features I have considering. So what are those features? First one, policy bind date, and I'll be having the customer, of course, how many months he's been there with the with that particular policy, or he'll be paying those policies. That is also one important criteria. Like there's various features I'll be having. Using these, I will try to predict the whether it is a fraud, claim or not. So first, we will be doing the exploratory data analysis. So since it is a classification case, first we have to know whether it is a balanced data or not. You can see here, 700 data we have for the no. It is not a fraud case or fraud claim, and we have over 300 as fraud. So obviously it is, frauds won't happen that frequently. That is the reason we have maximum cases of non-fraud, and the very few cases are having the non-fraud cases. So these are the exploratory data analysis, and here you can see various, organizations, associate level, college level, high school level, where exactly we will be having the more number of frauds, where exactly the reports are, fraud cases are reported. So I can see this blue line represents the no fraud reported. When it comes to yes, that is orange color representing the fraud cases. You can see when it comes to associate level, the frauds are happening more compared to the college and then high school, and the junior level will be having then MD level, master level, like that. How the fraud cases will be reported in the various levels we have. So when you go through the data line chart, in that case, it will be giving you the all details and in which sector the fraud claims are happening more. You can see tech support. In that, fraud cases are happening a lot more compared to the any other sectors when it comes to the data. You can go through that. That are the inferences that we'll be getting from that. And so it is a correlation chart. You can see the dark red color representing the maximum correlation, and we'll be having the blue that represent the maximum correlation to negative. So here we'll be having the white color that represent not having any correlation. You can see maximum feature doesn't have any correlation, but small features will be having, those comes under. So some will be having features that are nominal. So we won't be considering those features anyway. And here remove wherever, see most of the features doesn't have any correlation, right? So what we'll be doing, we'll be removing all the features that doesn't have any correlation. So among that, you can see here policy number, since it is a nominal data, we won't be able to infer anything from the nominal data. So I'm simply removing that. And policy bind date we will be having, that is also I'm removing. Insert dip, so it is a code, that is also I'm removing. And location doesn't give you any data, in that case also I'm removing. These are the features doesn't give any proper information and doesn't have any correlation. In that case, I'm simply removing those features. And then we'll be doing the data pre-processing. Whatever the categorical data I'll be having, I'll be trying to convert those into encode. I'll be doing the encoding and converting into the discrete values. Since it is decision tree, whatever the continuous data we will be having, it will automatically convert into the discrete value. So we don't need to worry about it. Even we don't do the scaling, it will take care of. Decision tree will be taking care of that issues as well. So we don't need to go through much pre-processing when it comes to decision tree. So in order to build the model, first we have to split the data into train and test. And based on the trained data, I'm simply training the machine learning models, and then I'll be getting the output. So you can see here, test score I have got about 76% accuracy. 76% accuracy we have got, and yeah. So in order to go through, I mean, when you have unbalanced data, it is always a good option to go with the F1 score and precision and recall. You can see even the F1 score is performing pretty good when it comes to non-reported cases, but when it comes to S-reported cases, it is not performing great because we have very less amount of data when it comes to reported cases. So it is a very base model since we have just 1,000 entries on 1,000 records, and based on that only we'll be building the model. So it is a base model, it is fine. But if you want to get into that and clear, if you want to improve the accuracy of that particular fraud cases, in that case we have to add more features as well as more data related to the fraud cases. So among these, it is ROC curve, how good our model overall it is performing. That is the reason we'll be having this. So how much? I mean, it is giving barely about 60 to 65% accuracy it is giving. So it is not a best model, but it is a good model to start with. You can say it is a base model. We'll do the same for the coding. In order to import the data set, I need to have the pandas library first. I'm importing the pandas library, and then I'm giving my look at it. Since I have already uploaded the data frame here itself, so I don't need to give the path. Simply give the data set name. In that case, it will automatically import it. So these are the features, the overall features I'll be considering. So index. So what are the columns we will be having in our data? So these are the various columns we'll be having. Of course, all the features are not necessary because 40 features we'll be having. So I'll be finding out whether we have any null values in our data. If we have, how many features we'll be having null values, that I'm looking into. So you can see here, null values just in one we got. And so what kind of, to check how many fraud cases we'll be having, how many non-fraud cases we'll be having. For that, I'll be having this bar plot. So it is a non-fraud cases, over 700 we'll be having. It is a fraud cases, it is over 200 we'll be having. It is not a balanced data set. In that case, you might not be getting the good accuracy as we have seen. Instead of that, we can simply go with the small technique, synthetic minority or summary technique can go and you can balance it. So there are same inferences that we got previously that I have explained in the PPT itself. And this is the correlation. Since we don't have much correlation, whatever the features not having the good correlation, and simply removing all those things. And then data types, which one it is holding. Policy, what kind of data type it is holding. Age, what kind of data type it is holding. Like various will be having what kind of data it is holding. It is showing that. So whatever the categorical data will be having, I'm simply converting the whole thing. So these are the objects will be having it, various incident object, incident type, collision type, incident severity. So these are all objects. It won't be taking directly. Instead, what I'm doing, I'm simply converting those into discrete values. So I have converted the all data points into the discrete, and now I'm training the model. In order to train model, we need to have the confusion for the evaluation. So these are the libraries, various libraries will be having. From SQL matrix, import the confusion matrix. So in order to evaluate, we will be using this data. And from SQL matrix, import the precision score. And that is also we'll be using for evaluation, recall, and model selection, train test split. So whatever the data will be having, the whole data will be splitting into train and test, right? Train and test. Whatever the train data will be having, using that I'll be training the machine learning model. Using test data, I'm checking how good it is performing. So I'm importing the decision tree in that DT classifier. Since we are going with the classifier, So I'm importing the decision tree classifier, fitting the train data into the machine learning, so that using that, what exactly here we are doing, using the train data, I'm simply training the machine learning model. And now I'm checking how good it is performing using the test data. How much we got accuracy? About 76%. It is not the bad, but it is not good as well. And predicted values and the actual values array we will be having, since we have just two classes. These are the actual classes and these are the misclassified classes. These are the misclassified. ROC report, you can simply go with the ROC in order to tell how much accuracy that you got. And since it is a imbalanced data set, you can go with the F1 score as well. So for the non-fraud, it is giving good accuracy, but when it comes to fraud, it is not giving good accuracy, obviously, because we have lack of data or lack of entries. We haven't considered the maximum features, maximum data. So that is the reason it is not giving less accuracy. It is the imbalanced data set as well. Imbalanced data set as well. So here we are going with the ROC, sensitivity as well as specificity. How good our model is. How much is? It is 70%. It is giving the accuracy of 70%. And among these features, whatever the features, see, it is a very base model. If you want to improve it, whatever the features, important features will be having that, you can take those features into the consideration, and you can rebuild the model. So feature selection, we will be having among these features we have taken. Which one is the most important feature? So among all features, so these are the features are important. You can simply go through it. Incident severity, major damage. Based on that, we will be going with whether it is. I mean, we can easily able to classify it. If it is a major damage or accident, in that case, we can say it is not fraud at all. And if it is not, in that case, we'll be having various other ways. Based on that, we will decide whether it is a fraud or a fraud claim or non-fraud claim. So this is all about the decision tree algorithm, guys. I hope you've understood something. I mean, you've understood what exactly decision tree is and how we will be using the decision tree in the classification. What are the advantages we'll be having when it comes to decision tree, and what are the disadvantages we'll be having when it comes to decision tree, and how we will be implementing the decision tree when it comes to use cases, real-time use cases. Real-time use cases. Yeah, that's it for today, guys. Yeah, thank you for joining the session, and in next class we'll be discussing the regression part. Regression, what exactly the regression is, what is the mathematics behind that regression, and we will be taking one use case scenario and we'll try to understand how we will be implementing the linear regression in real life. And yeah, that is it. I hope you will be joining in the next session as well. And yeah, have a nice day, guys. We'll see you in the next session.